Hey, this is Mr. Hansen. I'm looking at a graph with you, and today we're going to be working with quadratic functions. So the context for this graph is a rocket is shot into the sky with a velocity of 96 feet per second, and it's shot from a 100-foot platform. So we have time here in seconds and height in feet. Let's put feet right there. Okay, we want to take a look at this graph and pick out some of the landmark features or features that help us to understand the graph. So first of all, where did the graph, where is our initial starting point? It's probably going to be at time 0 and height 100. So 0, 100. You can see that crosses the y-axis there, so that's the y-intercept. Okay, from there, over time, your rocket is increasing. It's going higher into the air. The height is increasing. And we can see that after 3 seconds, we've reached 244 feet, and that's called a maximum. From there, we're going to go lower and lower and lower, and then we can see that point C says that at 6.91 seconds, we're at 0 feet. This is called an X-Intercept. Crosses the x-axis. So this is an important piece of information because it's telling us when the rocket hits the ground. And after 6.91 seconds, we really don't need any more information than that. So those are kind of the three very big features. But let's talk about what's happening to the graph from left to right over time. So I'm going to write domain and range. Domain. I'm just going to write graph. Okay, and there's a difference between the domain for the graph and the domain for the real world situation. So domain graph, it looks like it could be all real numbers because you could put in a very large negative number and still get something out. It would be a negative territory for y, but you'd still get something out. So it's kind of like you put in a number here and it's going to come out way, way down there. Or you put in a number here, it's going to come out way down there. So the domain for the graph is negative infinity to infinity. Sometimes we just call that all reals. Okay, the range for the graph is going to be every number all the way up to 244. After 244, you're not going to get any higher. So you could say negative infinity to 244, or another way to say it is y is less than or equal to 244. Either way works. Okay, so that's kind of important. Now let's talk about the domain for the actual word problem. So we're starting at 0 seconds. We're not starting at -1 or -2 seconds. So domain in context. So we're going to go from 0 seconds to, well, once it hits the ground, things are over, 6.91 seconds. We're going to include 0 and 6.91. So there's the domain in context. And the range in context, we're going to go, our maximum height is 244 and our minimum height is 0. So we're going to go 0 to 244. Okay, next question. Over what interval in the context is the function increasing? So interval of increase, we're going to talk about the context again. So this time we're going from 0, going from 0 all the way over to right about there to 3. And if you plugged in any number for x from 0 to 3, you can see we're going upward on the graph. So 0 to 3 is an interval of increase. And technically, I always kind of second guess myself on this because this is one of those things that could go either way. But at 3, is it increasing or decreasing or neither? It's kind of just hanging up there in the air. So I'm going to put this. It's not really increasing anymore. And I don't know, you might see other people put a bracket there instead of a parentheses, but I'm going to put a parentheses for right now. Okay, interval of decrease. So we're going from 3 all the way to 6.91. And we're including 6.91 in there. Okay, I think this is about got it for this one here. But every one of these things is really important. Y-intercept tells us, how high the function was when we started. The maximum tells us the maximum point we're going to be at. The X-intercept tells us after how many seconds we have reached 0 feet. The domain and the range let us know what numbers you can put in for an actual graph of this, and then the domain and context and range and context give us the numbers that's a little more limited, that gives us the numbers on the context, and then the interval of increase and the interval of decrease. One last thing I just wanted to point out is this function right here is the function or the equation that made that graph right there, and it's got 3 terms. The first term is a negative, and what's happening there is gravity is the first term. It's what's pulling the rocket back to the Earth. The second term there is velocity, so it's shooting the rocket up in the air. And then the third term is your original height. Original height. And we will discuss this in greater depth, how the equation relates to the graph later on. But hopefully this gets you an idea of where to start with quadratic equations. Thank you and have a good day.